To determine the image of 3, 4 under a rotation of 60 degrees about the origin, let's start by plotting the said point on our Cartesian plane. You have here 1, 2, 3, and 1, 2, 3, 4. This is our point, 3 and 4. This is where our initial side should be written. Okay, that's our initial side. So let's do it again. Okay, because if we talk about the rotation of a point and given an angle, we are going to determine the location of the terminal side, and in that terminal side, the image is actually contained. Take note that our angle here is 60 degrees, so it's actually positive. So we're doing it counterclockwise and reaching 60 degrees. We don't know if it's in the second quadrant or in the first quadrant. What we are sure of, it's not in the third nor in the fourth. To determine it further, let's use this formula here. The formula is indicated by the cosine theta, sine theta, negative of sine theta, cosine theta, times the components of your given x, x sub 1 and x sub 2, or for some cases, x and y. Okay, so we know that our x is at 3 and 4, and our theta is 60 degrees. Hence, the rotation or the image of the rotation for 3, 4 is identified here as cosine 60 degrees, sine 60 degrees, negative sine of 60 degrees, cosine 60 degrees times the components 3 and 4. Let's start by simplifying first the matrix with trigonometric ratio. Cosine 60 is we know to be 1/2. Sine of 60 is actually square root of 3 over 2. Here, negative of square root of 3 over 2. And you have here 1/2 to be multiplied with 3 and 4. And the product here is very defined. That's a 2 by 2 matrix times 2 by 1. So we are expecting a 2 by 1 matrix. It could be in this form or a point just like this one. So let's continue. You have here 1/2 times 3 plus negative square root of 3 over 2 times 4. That's for your first component. The second, you have your square root of 3 over 2 times 3 plus 1/2 times 4. Allow me not to simplify this and that, because I would like to come up with a possible singular rational expression here. So you will have the form 3/2 minus 4 square root of 3 over 2. Okay? And then, for the second, you will have here 3 square root of 3 over 2 plus 4/2. Again, I'm not going to simplify that, because what will happen here is this. I can combine them into one expression. 3 minus 4 square root of 3 all over 2, and you have your 3 square root of 3 plus 4 all over 2. Or in a form of a point, the rotation along the given degree is actually identified. By the way, you can write it rotation of 60 degrees, but generally it's something like that. Okay, let me just copy this one. I was not able to show that in the previous video, so let me just be consistent. This is actually 3 minus 4 square root of 3 all over 2, and 3 square root of 3 plus 4 all over 2. If you would like to come up with a approximation in decimal with decimal notation, so that we can actually probably plot this on our Cartesian plane, it's approximately negative 1.96 for our x, and for our y, 3 square root of 3 plus 4 divided by 2 is actually approximately 4.60. Okay, as we can see, it's on the second quadrant. So basically, it's a second quadrant, 1.96 or negative 1.96. It's almost 2, but it's not 2. And then 4.6. So you have here 1, 2, 3, 4, almost there, half. So this is actually the location. So basically, our assumption earlier is is probably there, close to accuracy. And this would be our terminal side. Okay, so we have shown here now that this is really the rotation on 60 degrees, and the point there is actually identified with this value or this form. Okay, so that's how we identify the rotation of this given point 3,4 about the origin under the rotation of theta being 60 degrees. Thank you very much for watching.